Good evening, everybody. Mr. Motorhon here, and I wanted to do a quick lecture to walk you through some examples similar to what you will see in your Delta Math assignment for today. I think if you can follow along with these three examples, you should be in good shape, and I'm only going to ask you to do about 5 or 6 on your own just to get the idea, and that's all I really need you to do. So I highlighted the topic for today's lecture, which is solving exponential equations with a common base. So I'll explain to you what I mean by that right now, but the first example that we are going to go through is right here. So these are what your Delta Math problems will look like. So I'm going to go ahead and write that same example down here, and it is 36 to the 2x plus 5 power is equal to 216 to the x minus 1 power. And right now when you're looking at this equation looks really complicated. The numbers look really big, and you're probably like, I have no clue what to do to solve this. So that is why I have included over here on the side this handy dandy table, which I would recommend that you keep handy to solve problems like this. So the keyword in this lecture is right here in the title where it says common base. So let me explain what I mean by common base. You'll notice right here in the equation, so we call this down here under the power, under the exponent, the base. So each side of this equation will have a base. On this side, we would say that the base is 36. And on this side, we would say that the base is 216. Now, the key to solving this equation is to realize that both these numbers, 36 and 216, have something in common. And that's where this table comes in handy. So I'm going to go ahead and go to the table, and I'm going to see if I can find these two numbers. So I don't see anything 36 or 216, 36, 216, 36, 216, 36, 216, 36, 216. But if you look in the 6th column, you'll see right here you have 36. And in that same column, so that's the trick, you should see you have both. So if I zoom into this really quick, what I want you to realize is that what they have in common is they can be reduced to the same base. So notice that both of them have a 6, right? So you can't tell immediately, but if you look at this reference, you will see that 36, another way of writing 36 is 6 to the 2nd power, and another way of writing 216 is 6 to the 3rd power. So that is that's what we mean by they have a common base. They both share that number 6, and that's going to really help us solve this equation. So what I'm gonna ask you to do is step 1. Let me make it a little bit bigger. So step 1 is going to be rewrite with common base. Okay, so if I do that, the table really helps here because I can see that another way of saying 36, so this used to say, so pretty much I'm rewriting the base. So remember I said that this part was the base, and this part was also the base. So each side has a base. And before this table, this side said 36, and this side said 216. If I go to my table again, I see I can actually substitute or rewrite both of these bases as powers of 6, which is really going to help me. So instead of saying 36, I'm going to say 6 to the 2nd power. And instead of saying 216, I'm going to say 6 to the 3rd power. So now you're like, okay, I see what you did, but I still don't understand how that's going to help me solve. And the key to this is to remember one of the rules that we talked about at the end of last week. So if you remember, we talked about 3 rules, the multiplication rule, the division rule, and the third one that we talked about was called the power rule. So if you remember what the power rule said, it pretty much said if we have some base to a power to another power, which is actually what we have right here, one power to another power, we can simplify that as that base to both of those powers multiplied. So let me clear some space. I thought I was not going to need as much space, but that's okay. We'll be creative down here. Okay, so this is going to be our key property right here, the power rule. Okay, so if I go to this side, so if I go to the left-hand side, I realize that I have 6 to the second power, and I'm going to write this in a different color, to the 2x plus 5. And then on the other side, I have 6 to the third power to the x minus 1. And so hopefully you're seeing that this is exactly what the power rule says we can do, is we can take one power and take it to another power. So a simpler way of saying this would be 6 to the 2 times 2x plus 5. So I just applied the power rule. And on this side we could say 6 to the 3 times x minus 1. Okay, so now that we applied the power rule, actually I should write that as step 2. Apply power rule. Now you will notice that the equation looks a lot simpler compared to when we started. When we started, we had these big scary numbers like 36 and 216, and now we're down to both sides that say 6. So here's the beauty. The beauty is when we solve equations, when we have things that are common on both sides, that kind of makes it simpler, because we know that we don't have to focus on making those parts equal. But what we do need to focus on is we need to figure out how to get these powers to be the same. So we successfully got both bases to be the same. Now we want both powers to be the same. So we can actually just kind of ignore, so we can pretty much ignore this. We can ignore the bases because they're the same now, and we can focus on these 2 powers. So our goal now is to try to figure out where does 2 times 2x plus 5 equal to 3 times x minus 1. And that hopefully looks a lot simpler to you, because it should remind you of a pretty basic linear equation that you solved in integrated 1 and integrated 2. So we're going to go ahead and solve it real quick. First step, we're going to distribute. So that's going to give us 4x plus 20 is equal to, distribute again, 3x minus 3. And then we're looking for like terms. I see a 4x and a 3x. So I can bring one of those over to the other. So I'm going to move this 3x to the other side. So that's going to be 1x plus 20 is equal to this will cancel. This will cancel. And let's see. So 1x plus 20 is equal to minus 3. And I can subtract 20. Subtract 20. And again, this will go away. cuenta. And I pretty much get left with 1x equals negative 23. So that's my answer. X is the value 23. Okay, there's nothing ever wrong with checking, so I'm just gonna show you how you can check that your answer is correct. Check, right? So we knew that we were trying to solve this. 4x plus 20 is equal to 3x minus 3. And so I'm going to take away the variables. And if I believe the answer to be, oops, not enough space, but if I believe the answer to be negative 23, I'm going to check that. So let's see, this will be negative 92 plus 20 is equal to negative 69 minus 3. So if I simplify this side, I get negative 72. If I simplify this side, I also get negative 72. So that is a very clear indicator that I've done this right. So this is definitely my answer. X equals 23. Sorry, negative 23. Yay!